Hello, welcome back. This is an alternate video for episode 38, where I solved Vector Math Coprocessor, my custom specification that I created in episode 37. If you want to try this puzzle yourself, there's a link in the description. Feel free to do that now, because I'm going to talk in full about the solution that I used for it. So anyway, interesting point, I made some comment changes in the Lua script, and this checkmark changed to an exclamation point when I did that. I guess that makes sense, so it has to re-verify the solution if the script changed. So, some important points here. Turns out this was kind of hard. Felt about in line with post-game Avalon City difficulty, but I did get it done. And I had to make a few little changes to the script. So I'm going to open this up. So I have a solution here. Those are the stats that it ended up being. So I'm going to walk through this design and explain how it works. Important changes. I had my cross-product definition wrong. Those pluses were supposed to be minuses. I was so focused on getting the operand order right, because it's a little complicated, that I got to get the operators the way they are. Anyway, so I fixed the Lua script. That's not there. It's here. Yeah, so Lua script needed a few changes. Cross-vector is implemented a bit differently. Turns out number rounding behavior in Lua had to be massaged a little bit. So I have this truncate float function that I'm using for all of my multiplications and divisions here, just to get it to behave the way that I wanted it for the behavior in here. Anyway, so not much changed here. I fixed some typos, I had some components wrong in here, and I had these operators as pluses. So yeah, that's not how you cross product. You do a minus. Technically, it doesn't really change the puzzle much if I did do plus here, but it would be an incorrect thing. So it's just better to have it be minus. Anyway, so the Lua script's all fixed up. I had to debug that at the same time that I was writing this program, which was a bit of an ordeal, but I did get it done. So, everything starts with the radio. By the way, the layout here was a little bit of a nightmare. I had this huge wire snarl that I had to rearrange like halfway through implementing this whole thing. But anyway, so to start out, listen to radio RX. Sure, yeah, so we know what that specification is. The fundamentals of this didn't change, just some small details and debugging and stuff. So when you get a 1, compute cross product. When you get a 2, compute dot product. And this is all on fixed point numbers with 1 decimal place of precision. So basically when you multiply 2 together, you gotta shift 1 digit to the right to get the correct, correctly placed decimal on the fixed point output of that. So anyway, it starts here with the radio. I listen for anything that's not a -999, and when I get something... Yeah, so whether I get a 1 or a 2, a cross or a dot product, both of them have an input of 2 vectors, x, y, z, x, y, z. That's not explicitly said here, but I think you can infer it okay, and it makes sense. Also realize that saying stuff like x1, x2 here does overlap a little bit with like the namespace for XBus pins, but it's fine. It's not that ambiguous. But yeah, the spec could be clarified a bit. I don't feel the need to. Some of the official specs were a little vague, so I'm getting my revenge that way, I guess. I don't know. Anyway, so when I get a 1 or a 2, when I get a 2 or a 1, regardless of which of those it is, there are 2 vectors that come in that I'm going to have to operate on. So my approach to this ended up being, since this is a lot of data to store and operate on, I had one idea where I could have like a bunch of microcontrollers and just shuffle values around in registers and not use any kind of special storage for it. But it just felt like it made so much more sense to store both of the vectors in a 100p14. So that's what this does first. It loops through and copies the incoming vectors. Yeah, okay, so it uses actually the address line to know when to stop. Copies the incoming vectors into this 100p14. It does it in kind of a weird way. You'll see some instructions here you might not expect for just a straight copy. Originally, I just had literally 6 move x0, x2s in here. So that would write x1, y1, z1, x2, y2, z2. I'll talk about what it does that's different from that once I get to dot product. And, well, actually, I'll explain the whole thing here. But for now, let's just say that this inserts the incoming vectors into this data store in a special way. Then once that's done, it breaks out of this loop here. It moves whatever value it had read from the radio, the 1 or the 2, to x1. So that goes on to essentially an I/O expander here, because this already has to talk to the radio and the 2 thingies here. Doesn't have room to talk to everybody else. So anyway, 1 or 2 goes over here. The vectors are safely stored in that. This next microprocessor here is the one that actually transfers data over the radio. So it initiates the operations on the cross-product handler here on x3. So yeah, if x1 is 1, then I send 0 to x3 and move 3 parameters to the radio. If x1 is something else, a 2, then I move a 0 to x2 and wake up the dot product handler, which is down here, this guy. And then move the 1 scalar parameter out to the radio. So yeah, that expands I/O and wakes up the appropriate controller and forwards on its return value to this. But it doesn't actually send any data into it. All the data is packed away in this 100p14. So dot product's a little simpler. Let's do that one first. So this, when it's awoken, moves the value, the 0 there that awakened it, into the address line, the A1 line, x1, of this 100p14 that stores the input vectors. So it starts at 0, that's how that I/O line gets cleared, and that's how that 0 gets written to the address pin there. I could actually step through this, that's fine. Let me explain how it works first. So yeah, it sets the... let's step through it. That'll make more sense, actually. Yeah, okay. So you get a -9 to 9, nothing on that tick, nothing on that tick. So here we get a 2. Yeah, so it's going to write the vector there. And it's doing it in a funny order. Again, I'll explain as soon as I show you what's going on in here. But anyway, the 2 vectors are written to the first 6 fields of this. So that 2 goes there, it wakes up this thing with a 0. The 0 goes here for the left pointer, or sorry, the right pointer, the A1, which is already in the right place. And yeah, then that just wants to read its output and put it to the radio. So, what this does is it takes the data line, x0, and sends it off to this. This microcontroller over here is my multiplication function, my fixed point, 1 decimal place multiplication function. So when this is awoken, it gets 1 value, the LHS of the multiplication, then multiplies it by the second value, the RHS. So those 2 numbers are multiplied together, and then it uses this little helper, because I needed 1 more register than I had here. So it copies what it... Here, let's see that actually happen. So x0 goes to x3. So 6, it read x1. 6 goes here. And what else are you going to do? You want another input value to multiply. Then it just reads another value from here. So the reason this writes things in a funny order, instead of writing x1, y1, z1, x2, y2, z2, I end up writing them in interleaved order, so I do x1, x2, y1, y2, z1, z2. That matches the order in which I need to process the vector components for dot product. So even though they come in xyz, xyz, it was just much more convenient, so this didn't have to do address math or anything, to do xx, yy, zz. And I have a completely different way of handling addressing for cross product, because that needs each component twice, and in a kind of funny order. You can probably guess what that 200p14 over there is doing, but I'll go through it in detail in a moment. So anyway, I get the first 2 values, x1 and x2. So that's 6 times 1, which is actually 0.6 times 0.1, since these are fixed point numbers with 1 decimal place of precision. So yeah, just imagine a decimal point to the left of every rightmost digit of each of these numbers that come in. So 6 and 1 have gone in here. So 6 is there in AC. 1 gets multiplied by it, so 6 times 1 is 1. Yeah, sure. 6 times 1 is 6, actually. I know how to do math, believe it or not. There's a little extra bit of wire there. I know why that is. I'm gonna ignore it. Don't worry about that. Just that little blob of wire. It's not relevant to the puzzle, by the way. So, right. So I have 6 times 1 in here. This wants to get the output of that and add it to its AC. So basically what this has done is the x1 sent over there times x2 sent over there plus whatever's in AC already. So it's going to do this 3 times. So 0 plus x1 times x2 is pretty much what these 3 lines are doing. Anyway, so I copy my AC to dat for safekeeping because I'm going to do some DGT on it. That's how I shift to the right. I DGT 2, so get the hundreds digit in case there is one. There is not. Times when that would happen would be only if 10 is multiplied by 10, or 10 is multiplied by negative 10, or negative 10 is multiplied by negative 10. There is a very specific case that I think is actually broken with my implementation here that the test data never stresses in all 80 of its tests. But since that case is never hit, then I guess I don't have to worry about it. This does pass all the tests. Anyway, yeah, so the only time this would ever come up with anything other than a 0 is if I have 2 10s being multiplied by each other, either 10 or negative 10 on either side. Anyway, so mul 10. Mul 10? Yes, right. Because I did a DGT on the 3rd digit, I shifted it all the way to the 1st digit. Then I need that to be the 2nd digit, because I'm shifting right by 1. That's why I do the mul 10. Alright, so that's what puts the hundreds digit that's now over here into the middle. Okay. So then I copy that to this little helper here, which just kind of holds on to the value for a moment because I needed a 3rd register, and you are the 3rd register, basically. So it wakes this up, and you're more than just a register, though. You're going to add 2 values together. So this is where I recompose my shifted right number. So I send it the... I can actually move that mul 10 in there, and that'd be fine, but it doesn't matter. There's plenty of instruction space in both places. Doesn't matter which one does it. Anyway, yeah, so first value comes in there. Then I recopied that in here, because I destroyed it with the DGT. You want to add a value, so you're going to wait for that to come in. Then I DGT 1, so I get the 10s digit in the 1s digit. That one's already in the right place, so I don't have to do a multiplication after the DGT. And then I send it to x0 again, so this adds the 2 together. Huh, this could actually literally just be SLX x0, move x0, x0. And instead of moving that there and moving that here, I could just add x0. Yeah, I really did just need 1 extra register for a moment. Okay, that would probably save me some lines. Yeah, that would save me some lines. Okay, that's an improvement that I could make. But I'm not going to right now. So anyway, that gets the recomposed number after it's added together, move AC x0, and then that resets AC to 0, right, yeah. Yeah, I could save like 4 lines? Yeah, a bunch of lines. Anyway, move x0, x1. Yeah, so then it takes the output of this and sends it back to the thing that invoked it. So the multiply function returns with 0. Because 0.1 times 0.6, using truncating integer division, does come out as 0. Because that comes as 0.06. And it only goes to the 0.0 as far as decimal precision is concerned. So we get a 0 back. I add that to my ACK, and oh, by the way, this is going to end up with 0. So going through this is not the best example. We won't see any numbers actually do much of anything, but it's fine. You'll at least see the logic. Alright, and then I test the address, x1, a1 here, to see if I've landed at address 6, which would mean that I'm done, that I've read all of the input vectors. I haven't, so we're going to do it again. So now 0.1 times 0.9. Once again, that's 0.09, so you get a 0 back. Add that, right, so this is now y1 times, so plus this add y1 times y2, this x0 and this x0 is what's happening there. So we add 0 to 0, we're not done yet. Now we're gonna multiply negative 0.6 by negative 0.1. A lot of low numbers in this first dot product input, so yeah, it just doesn't have any numbers to come back, really. These are very, very low precision vectors. I wish I had the space to give it like 2 decimal places of precision or something, but it just doesn't work with the way I have to shift things right here. The extremely low number limit of Shenzhen I numbers is just too restrictive for like useful vector math. I'm pretending this is useful, but the precision is so low you couldn't do much with this processor. Still though, you get to implement the logic and it works fine. Just pretend there are more decimal places here. Anyway, yeah, so last multiplication. So this is z1 being multiplied by z2. It read the 2 values, it sent them, and then the add does this last plus here. Okay. So all that happens, you come back with a big fat 0 and send it off to here, which sends it to the radio, and it wrote it, and it's happy. Great! So we did a dot product. Let's do a cross product now. This first page of test data, the one that the random gave me, is actually pretty good for a lot of things, because it has 2 cross products in it, it has several different dot products, and it exercises a bunch of cases of different things. So anyway, so this time we get a 1 in that. Write the interleaved vector. Yeah, so what this is doing, right, let's actually look at this time. So it starts at 0, with that move 0, writes x1 to that, then just reads a value to nowhere, skipping a value, and writes another value here. So yeah, each time through it writes and then reads to nowhere. So every second one gets one. So this is Z1 going into the address 4 slot right now. No, not yet. This was Y1 having gone into the address 2 slot, then skipping address 3, and you're sitting at address 4. So I have 2 tests for where the address is, actually. I was real happy with the way this worked out, because it has to go 0, 2, 4, 1, 3, 5, and then stop. But I was able to fully express that with just an address line here that it just reads from when it needs to. So anyway, this is Z1 going into this slot, done, and then skip the next one. Okay, so X3, the A0 line, has landed at 6. So this is how I know that I need to switch over to writing here. So I avoid having to do any address arithmetic by just having fixed values. So I have the move 0, X3 here to position it there. Then I can detect when I land there that I need to reposition it back to 1, doing this. So move 1, X3. That positions the right head for the incoming X2. And 7 detects when it's done, because it will have just written Z2 and skipped 1 and therefore landed there. So that's how it knows to break out of the loop. We're not there yet, so still looping. So X2 goes there, skip 1. Y2 goes there, skip 1. Z2 went there, it skipped 1. We're not at 6, so we don't need to loop to 1, but we are at 7, so we can break out of the loop. Great! So then the 1 goes over here. This wakes up cross product and is going to want to move 3 values from it to the radio. Okay, so you're awake, your input vectors are stored in there. Wires go, let's see, this, oh yeah, this one was the worst nightmare to wire. It's pretty hard. So this is most of the cross-product logic, but I needed a helper here for looking up, well, two helpers, kinda. So these three together form the cross-product logic. So I got these interleaved vectors here, and I need to read from a bunch of different addresses. I do y1, z2, z1, y2, x1, z2, z1, x2, x1, y2, y1, x2. I thought it would make sense just to have 100p14 that gives the index in here in the order I'm going to have to read it for doing this operation. So address 2 is apparently y1. Yep, that makes sense. 0, 1, 2, that's where y1 gets written. Address 5 is z2, that's the last one. And so forth. All the way down here. The negative ones are just to indicate there's no data there. I needed 12 values and it fit great. So I'm glad I chose 3 component vectors. Good thing I didn't try to do this in 4 dimensions. Cross product doesn't work in 4 dimensions. Dot product does. Cross product does not. I think? Let's see. Is there a cross product definition for 4 dimensions? So in 2 dimensions, the cross product is a scalar. It's just the z component of a 3-dimensional cross product. In 3 dimensions, cross product is a vector. In 4 dimensions, it's something else. Anyway, that doesn't really matter to the puzzle here. We're just doing 3-dimensional vectors. So anyway, what's nice about this is it's completely independent of the layout I choose for putting values in here. I could go xyz, xyz, I could go xx, yy, zz, which was more convenient for dot product. When I first laid out this table, I had it as xyz, xyz, because I hadn't figured out what to do for dot product to that point. And all I had to do was change my numbers in this table for the changed dot product layout, and it worked great. So that made a lot of sense. The harder part was figuring out how to interleave on input here, but I made it work. Anyway, yeah, so this just has all the indexes of those operations in order. Now, it's a bunch of I/O lines here. This needs the communication to the outside world here, and communication to its inside world of address of this. Technically, I could do without the address line here if I just did 2 junk reads to reposition the read head back at the start. Except it doesn't work with the way the wiring is. However, now that gives me ideas. That might actually let me eliminate this microcontroller? No, you need to do a lot of things. Okay, so right, logically, what this needs to do is take input, give output. So that's 1 XBus pin. Read an address from here, that's 2 XBus pins. Write that address to the address line of this 100p14 where the vector data is stored, the inputs, that's 3 XBus pins. Read the data at that address, that's 4 XBus pins. And then communicate that data to the multiplication function over here, that's 5 XBus pins. So no, it's impossible to eliminate your helper, unless like somebody else would somehow take over that duty. But anyway, I need 5 XBus pins to do cross product with this logic the way it is. So I have those 2 controllers doing the pins that way. And this one also has a line to the address pin because I set it to 0. Okay, so move x0, x2. So yeah, the incoming 0 that wakes you up resets this read head to 0. Okay? Whoa. Oh, right. It took me back there, of course. So then I need to do 3 pairs of these, basically. So I'm doing this for loop thing a little differently now here. I used to write these as like move... Oh, hang on. No, we're not there yet. Sorry. I'm getting ahead of myself. Anyway, yeah. So I need to do... There are 3 pairs of operations here. Something times something minus something times something is one component that gets written out here. So we do 3 of those, and then we're done. So this does that loop of 3, doesn't it? Yes, it does, but it keeps track of where it is by the address line to this. Yeah, okay, so once the address lands at 12, once I've read 12 values... 12? 12. Yes, 12, of course. Yeah, 12. Once I've read 12 values, then I know I'm done and I can break out of the loop. Anyway, yeah, so we're looping until this hits address 12 here. And in that loop, I send a 3 over to x1. Right, so here's what I was saying about this for loop thing. What I have been doing a lot is slightly power inefficient. I've phrased loops such that I start with a number, like I'll say move 4 to ACK when I want to do an action 4 times. I'll then, let's see, how did I do it? I sub 1, do the action, test if it's 0. If it's not, then loop back around and do that, basically. I can phrase that slightly more efficiently here. What this is saying to the thing connected to its x1 is basically, when I wake you up, do your action, but also do it the number of additional times I tell you. So if it moved a 0, it would do the action once. If it moves a 3, it does the action 4 times. The rephrased for loop there, I think, is slightly more efficient because it involves one less subtraction. Yeah, so it tests if I've already reached 0 before it does the subtraction. So it does the action first, then it tests if it's done with the loop, then it subtracts and jumps back to the loop. And I think that saves 1 instruction per iteration through the loop, I'm pretty sure. Anyway, just decided to do it that way. So do your action and also do it the additional number of times that I tell you. The action that this does is to read, okay, move x3 ACK. Yeah, okay, so that's your counter. The loop action is to read from this 200p14, move that value that you read to the A1 line of this 100p14. So set the address of set the A1 address that I'm going to read from. That set it to 2, yep, which is what you read from there. And then move the value at that address from the D1 line, here in X1, over to the communication to your caller. So you return that value, and then you continue doing that right up until ACK hits 0. So that's straightforward enough. We don't need to step through that to see it. But anyway, when you receive the first value from here at the address read out of there, you want to send it to the multiplication function, which is on x3. So that goes over here to this guy. So that's coming in with the y1 first. So this is y1 times z2 right there. So y1 times z2. So it sends it off to multiplier. Multiplication gets its RHS in the second one of these. That's the -10 here. So we're multiplying -1 by -10, or -0.1 by -1, basically. So this goes off and does it, and then I store the result of that in ACK. By doing a move instead of an add, a sub. No, anyway, well, yeah, so I need to store the result of this operation so that I can subtract from it, because the second half of the operation will need that subtraction. Okay, so great. This goes off and does its thing. You're already ready to send the address, or sorry, the value of z1, but this isn't ready for it yet because it's waiting for multiplication to finish. So multiplication happens, it comes back with 1, which is correct. 1 goes out there, and that goes into ACK. So we're going to be subtracting a value from 1. The value we'll be subtracting is determined by this 3 going in here, and then that 10. So it's 0.3 times 1, essentially. Yeah, so I want to subtract result of this operation, z1 times y2, which is computed over here, from the first result that was stored in ACK. Oops, right, yeah, so it'd be here. So that finishes its job. It outputs 0.3 in fixed point, and we ended up with -2 there. And that is the correct output value for the x component of the crossed vector. And there we go. then it just does, okay, so it checks if it's done, if this pointer has landed here. It has not yet. It just does the same thing for y component of output. So x1 times z2 minus z1 times x2. Goes through all that rigmarole again. And ends up with 4 minus 0. Yep, 4 minus 0. That's 4. That goes there, and it is correct. Same thing for z components. Looks like this is going to be... wait, hang on. So z is... Have you done it already? Move x3 ac. Right, you haven't done it already. The result is -4. So it's going to be -4 times... Or sorry, -4 minus... Was that 0? -4 minus 0. -4. Great. Output, and it's correct. And there we go. That's cross product. So yeah, that's the whole program. Works great. I still think there is a problem here. Since this does, this performs DGT operations on 2 and 1, I believe there is a case here, histograms are not available for custom specifications, by the way, where this would get a 10 and a -10, multiply them together, get a negative number. Oh wait, no, that would work just fine. It just so happens that the second number of that is 0. So you'd get -1 in this DGT2, you'd mul by 10, so you get -10. Then when you do the DGT1, you just get a 0. You don't get a -0. Okay, if my numbers were any larger ever than 10 incoming, then this would be a problem. This would need special handling to detect the sign of, like, its incoming numbers. Go away. And, because it would, something would mess up. I don't know exactly what, but something would mess up the way this is written. If DGT, both here and here, returned negative numbers, I'm pretty sure... Would they, though? If I'm just adding those negative numbers together, though... No, I think I've convinced myself that that would actually do the right thing. The sign would be kept, and it would be output the right way. But I also think that because of the size of my numbers, I will never hit a case that does that. Okay, so I don't need special negative handling here. It just works out logically, I'm pretty sure. All right, cool. So yeah, that was my solution to this. I'm actually real happy with the difficulty balance of this. I didn't have to do any balancing. It just sort of happened the way it was. So yeah, this is like Avalon City difficulty, more or less. Took me about as long as one of those puzzles. And yeah, I'm happy with both my my specification design and my solution to it. Again, I could save some lines here by just making this... Okay, you know what? Fine, let's try it. See if I can get the line count down at all. So SLX X0. Move X0, X0. And yeah, so you just give it there for safekeeping, and what you do is instead of... Alright, where is it? So you mul by 10, you move it there for safekeeping. Move dat ac, DGT1. So instead of move ac X0 and move X0, X1, you add X0 and then move ac X1, right? Seems to work. Okay, so I saved 3 lines, and that'll save a little bit of power because now those lines won't have to take power. Okay, so I improved my stats slightly, I guess. Still feels bad to have this here just to be an extra register, but you know what? It's fine. Alright, so I have an alternate solution now that only uses 1780 power. That's actually a lot of power. Right, it's a lot of multiplications, of course. Those 3 lines were in an extremely busy part of the program that's used for, like, several times for every calculation. Okay, so those are my improved stats. Good stuff. All right, and also, by the way, since I want to show everything here, When I came back here, no, not prototyping new ideas. When I came back here to custom specifications, it just automatically detected that I had done this. And yeah, says, good work creating a specification. Maybe one day you will take my job. You will never retire, Jay. I won't allow it. I have been doing this for almost 40 years, so maybe after another 40 years I will get tired. He looks really good for his age. I wouldn't have guessed he's that old. Maybe he started at the company really young. Anyway, yeah, so that's custom specifications. I'm real happy with that. Next time we're probably going to go to prototyping new ideas. Unless I decide to take another crack at this. It'll have to happen at some point, but I think this one can happen first. And if I really, really want to put this off, I still have puzzle vaults, but I probably really need to do that before I break open the vault. Alright, cool. So see you next time for prototyping new ideas.